Hello students, welcome to IIT Foundation. So myself is Shivashankar. I am a physics teacher. Today we will continue the last topic. In the last topic, the vectors were doing the problems. I explained the example problem. So that is in one method we have seen there. So now today we are going to see the next method. Okay. So that method is determinant method. In the last topic we have taken the vectors here. The vectors has taken here a bar is equals to we have got there I cap plus 2 j cap plus 3 k cap we have taken, and b bar cross b bar is equals to we have taken here the vector 3 I cap plus 4 j cap plus 5 k cap we have taken there, and we have found the a bar cross b bar a bar cross b bar value we got here. A bar cross b bar is equals to minus 2 I cap plus 4 j cap plus 4 j cap minus 2 k cap we got there. Okay, will be check whether by another method we can check there whether it is correct or not. Okay, so we'll see there now determinant method. So here you write down there cross product of two vectors, given vectors. So one method we have seen there. So now we are going to see the determinant method, matrix determinant method. Okay, so for that we will write like this: a bar cross b bar is equals to. So we'll write a determinant method here. So matrix determinant method. Here we'll write a bar vector is that one. No? We'll write here I cap, j cap unit vector is the first in the first row, and in the next row we'll write the coefficients of this a bar vector, coefficient of unit vectors of vector here. So that is coefficient of I cap here we can write 1, coefficient of j cap is 2, coefficient of here that is 3, k cap is 3 then. Next for this we'll write here b bar, coefficient b bar here 4, 3, 4 and 5. Okay, so now here to do here determinant method, and see this is a 3 by 3 matrix. Okay, means 3 rows and 3 columns. So these are called as rows and these are called as columns there, means I, j, k is the first row, 1, 2, 3 is the second row, 4, 3, 4, 5 third row, and I, 1, 3, j, 2, 4 and k, 3, 5 is the columns. This is the first column, second column and third column. So it is a 3 by 3 matrix there. 3 columns and 3 rows and 3 columns there. Okay, that is called 3 by 3 matrix. In the 3 by 3 matrix here, to find out this determinant method, we have to close this first row. We have to close the first row and the first column. If we close first row and the first column, we will get here, we will see the 4 digits there, that is 2, 3 and 4, 5. So first we have to do the multiplication of these two minus multiplication of these two. Okay, so means here I cap, which one you are closing, that we should write here I cap into, and here we should take here plus sign, plus I cap into this one. Okay, first 2 and 5 has to be multiplied, it will come there 10. Okay, next minus 4 into 3, 2, 5, 2 into 5 it is a 10, and 4 into 3 minus 4 into 3. So like this we should follow. So here we will get the 12. Now here we have to take their minus. So for this unit vector plus, we have to take the plus. Okay, this is equals to. So now here this is a plus, now plus I cap. So this multiplication of these two digits and this difference minus 4 into 3, 4 into 3, 12 we got there. Okay, so minus. Now here we have to take their next negative sign for this j vector. Now here we have to close. Which unit vector we are taking there? That column has to be closed. and always first row has to be closed there. So if we close this, then we'll get here 3 digits, that is 1, 3 and 3, 5. Now here we have to do the multiplication of these two and subtraction of these two. Okay. So here it is 1 into 5, we'll get here 5 and minus 1 into 9. 3 into 3 minus 3 into 3. So here we'll get there 9. Next plus here cyclic order plus I cap, next minus j cap, next plus k cap we should take here, plus k cap into. So now with the last k cap, we are taking k cap now, this last column has to be closed and first row has to be closed there. Okay. So now remaining digits are here 1, 2 and 3, 4. 1, 2, 3, 4. So now we have to multiply these two and subtract the multiplication of these two, minus 2 into 3. Here plus k cap cross. Now the last column has to be closed and the first row has to be closed there, remaining these two digits. So now 1 into 4 has to be multiplied, 4 will come there, minus 6. So this is the here 4, 1 into 4 will be the 4 minus 3 into 2, 3 into 2, minus 6 will come here, minus 6 no. Okay, so now here what will get here? So 10 minus 12, so minus 2 I cap will get minus 2 I cap. So here minus j into 5 minus 9 will get minus 4, this is a minus 4 will get here, plus k cap into 4 minus 6 will get here minus 2 k cap, so minus 2 we can write here, k into minus 2. So now here we will get the equation like this, minus 2 I cap, minus into minus here plus 4 j cap and here minus 2 k cap, So this is the A bar cross B bar. So in the both the methods will get the same answer. See here A bar cross B bar we got minus 2 I cap plus 4 j cap minus 2 k cap. In the last class in that method, normal method also we got here 2 I cap plus 4 j cap minus 2 k cap there. So we can follow any method which is easy for you, that can be followed there. So the multiplication of vectors in the vector product or in the cross product will be do in these two methods there. Okay. So that is about the cross product of the two vectors by the determinant method there. So this is the concept of matrices. In the mathematics there is a concept will be there, that is the matrices. The chapter will be there. So in the matrices will be do the determinant method there. So this is the finding method of to find the determinant of a given matrices. So in that method, if you find out, then we'll get the cross product of the two vectors. Okay. Understood now? I will say here once again, A bar cross B bar. A bar cross B bar is equals to, see here we should draw here determinant, 2 lines we should draw there, this is called determinant there. In the determinant, so we have to write here the unit vectors of the two vectors. Unit vectors, common unit vectors are here I cap, j cap, k cap. Okay. And now the coefficients of these unit vectors are 1, 2, 3 for the first A bar vector. So what is the vector here we have written there? So the coefficient of that vector only we should take there here. Okay. So next B bar vector, coefficient of unit vectors of B bar vector, that is the 3, 4, 5. Okay. So now these are the 3 columns and 3 rows we have there. These are 3 by 3 matrices. So now to find out here determinant of this given matrices, we should do like this. So first column. So which unit vector you need to multiply here. So that unit vector, that row has to be, that column has to be closed, and first row always it has to be closed there. Then here we'll get there 2, 3, 4, 5 will be the digits will be seen. Okay. Now here first from 5 and 2 to be multiplied, 2 5s are 10. 10 we should write here minus minus 4 into 3. This is a minus 4 into 3. So here minus 4 into 3. We will get there minus 12 will get there. 4 into 3, 12. Okay. So next here we have to take there for the j cap. So it is in the first case here for I cap we should take their plus. In the cyclic order we will get there in the order there plus and minus. Negative we should take here, minus j cap we have to take. And here if we close this j cap column and the first row, if we close the j cap column and the first row, we will get here 4 digits 1, 3 and 3, 5. Okay. So now first then we have to multiply this, we have to multiply this 5 into 1, we will get here 5. Next we have to multiply this 3 into 3 minus 9 will get there. So 1 into 5 will be 5 minus 3 into 3 will get there 9. 3 into 3 will get 9 here. The next here plus we have taken minus now for j cap. Then for next one will come there k cap, that is plus k cap we have to take there. Plus k cap we should write there. So plus k cap into here. Now so k cap column has to be closed and first row has to be closed there like this. If we close them, then remaining here 1, 3 and 3, 4. 1, 2, 3, 4 will be remain here. This column, this one. Okay. So 1, 2, 3, 4 will be remain there. Now, so 1 and 4 has to be multiplied. Then we'll get here 1 into 4, we'll get 4 here. The next this one 3 into 2 minus 1 into 4 minus 3 into 2. Here we should do minus here, minus. So minus here also minus for while doing this one. Okay. So we'll get here minus 6. Now simplify this one here, 10 minus 12 will minus 12 I cap will get here 5 minus 4, sorry 5 minus 9 will get minus 4 j cap, and this one 4 minus 6 minus 2 k cap will get minus 2 k cap. So here minus 2 I cap plus 4 j cap, minus into minus here plus 4 j cap, and this is a minus into plus here minus, this is a minus 2 I cap plus 4 j cap minus 2 k cap will get there. Okay. So this is the, in the previous method we got that answer, and here in this determinant method also will get same answer. Here we got the same answer there. So which one is easy for you, that method to follow to find out the cross product of the two vectors. Okay. And here next we have the geometrical applications of this vector product. Okay. And in the physics there are many physical quantities are multiplied. So like we have the vectors can be multiplied there. Like there are the examples are there, no, in the theoretical, in the practical applications we have the practical applications of vectors. The practical applications of vectors, like we have the angular momentum. We have a angular momentum, angular momentum, angular momentum, angular momentum, angular momentum is equals to, angular momentum can be written as, it is the cross product of perpendicular distance into the linear momentum. Okay, cross product of r. So this is a cross product of perpendicular distance into the linear momentum. Suppose here a particle is moving, okay, at certain distance, this is a perpendicular distance, and here this is the momentum of a particle along this direction. The velocity of the body may be like this, and here this is a vector, position vector, this is r cap. So now in the perpendicular direction, there is a angular momentum will be present there, that we can see like this, the perpendicular momentum. So L bar is nothing but L bar is equals to R bar cross P bar. So this is a vector notation. So it can be represented as L bar is equals to R bar cross P bar, R bar cross P bar. This is the expression for the angular momentum. One more example is there, like we have the torque. Torque is nothing but torque. The torquer will say their moment of force. Moment of force. When we close the door, then we'll apply the force at the edge of the door, and we'll apply the force perpendicularly. Then the force of application of the on the door, it will be perpendicular from the axis of rotation. There is a perpendicular distance will be there, no? So then the moment of torque, it can be denoted by the tau bar. Tau bar is equals to, we can write here, R bar cross F bar, R bar cross F bar. Okay. Then couple actings. To open the tap or close the tap, to open the cap of a bottles, we'll use the torque there. It is a moment of force there, application of force in equal direction. Okay, so the torque will be rotated in suppose the same force at certain distances, same in the two directions, the same force will be applied, so that the torque will be developed there. So that is called the couple acting on the objects there, so that we can rotate the object in clockwise direction or in an anti-clockwise direction there. So even the example of the tap, opening of tap and closing of tap. Okay. So then that is about the torque there. Moment of force is said to be the torque, and angular momentum is nothing but it is the product of the cross product of the perpendicular distance from the axis of rotation and the linear momentum from the action of the linear momentum. Okay, and these are the some of the examples for this practical applications of vectors. Torque and the angular momentum are the examples there. Okay, so then next we have the geometrical applications of vectors. Geometrical applications of vectors. Nice. So we have the parallelogram. So to find out the area of the parallelogram, we'll use this one. Okay, this is suppose A and B vector, and C and D is the parallelogram. Okay, so now area of the parallelogram, simply we can write, suppose this is and two vectors A bar and B bar are represented as the sides of the parallelogram. Then the area of parallelogram is given by the cross product of these two vectors, So that is equals to, here we can write there A bar cross B bar, And one more example is there, the practical application. This is the first one we can consider, the area of the parallelogram. If the two vectors A bar and B bar are represented as the sides of this parallelogram, then so we have the area of the parallelogram can be calculated by using this two vectors, by using the finding out the cross product of these two vectors there. Okay. So and next one is we have the area of triangle. Area of the triangle. Area of triangle. When the two vectors are represented as the sides and height of the base and height of the body is given by half of the this cross product of the two vectors, So this is the area A of triangle, So it can be given by using this formula. Half into A bar cross B bar. Half into A bar cross B bar will be the area of the given triangle. If the two sides, means vector A and B are used as a the side and the base of the sides of the triangle, then we can find out the area of the triangle. It is cross product of the half of the cross product of the two vectors. Okay, and if the two vectors are represented as the sides of a given parallelogram, then the area of the parallelogram can be given by the cross product of the two vectors. Okay, we can find out the area of the parallelogram and area of the triangle we can find out by using the cross product of the vectors. These are the applications, geometrical applications of the vectors. Okay. So now we are going to see here, next here we will see numericals, we will see there. See page number 56, fifth practice sheet is there here. So here more two concepts are there. So after doing these problems, we will be solve that problem for the exercise. In the exercise from 6th problems, there are that concepts will be required. Then that time we will be discuss them. So here it is given there, page number 56, practice sheet 1, concept based questions. Okay, concept based questions. First question is given, the direction of the cross product of two vectors can be known by applying triangle law of vectors, vector of addition, Ampere's swimming rule, corkscrew rule, all of the above. Okay, so first question, the direction of the cross product of the two vectors can be known by applying triangle law of vector addition, Ampere's swimming rule and corkscrew rule, all of the above. So which one is the correct answer? See, we have discussed that the to find out the direction of the cross product of the two vectors is given by right hand thumb rule or corkscrew rule. So option is here, third one. Third one is the correct answer. First question is, third one is the correct answer. Clear now? First one. So here practice sheet, fifth practice sheet. Practice sheet, fifth practice sheet we will see there. So first answer is option 3. Option 3. So it is the direction of the cross product of two vectors can be found out by using the we can say their right hand thumb rule or the corkscrew rule. So corkscrew rule. So suppose this is a screw here. So if you rotate, the rotation will be give the direction of the cross product of the two vectors, and the direction of the motion of the corkscrew will be give the direction of the direction of the cross product of the two vectors, and the rotation will give the plane of the two vectors. Okay. So next question is, the angle between the vectors a bar cross b bar and b bar cross a bar is. Okay. Suppose here for the second one, for this solution, let us consider here a bar is a vector like this is a a bar, and b bar is vector like this is a b bar. Okay, this is a b bar vector. So now here the angle between them, certain angle will be present there, and now the plane. So this we can write here a bar cross b bar. So this is a bar cross b bar. So this vector, it is perpendicular to this one and perpendicular to this vector. A bar cross b bar is mutually perpendicular. Okay, it is upward there. Now b bar cross a bar. So b bar cross a bar will be how? The b bar cross a bar will be like this. It will be downwards. It will be downwards means if it is moving in anti-clockwise direction, we will get the thumb. So rotation of this, the curled finger will be represent the direction of the plane of the two vectors. Okay. And the thumb will be represent the direction of the a bar cross b bar. Now if it is rotating in anti-clockwise direction, then the thumb. So then in a in clockwise direction if you rotate, then thumb will be represented downwards. Then it can be written as B bar cross A bar, B bar cross A bar. Okay. So now angle between these two vectors. Here angle between how much it will be? It is 180 degrees, no? 180 degrees or pi we can write there. So answer is 180 degrees. So option, correct option is answer option 2. Option 2. Okay. Option 2. We can give the example of this one. Okay. Suppose these are the two vectors, no? So this is one vector and this is another vector. Okay. So then if it is moving in a clockwise direction, then so it is in clockwise direction. Clockwise direction means it is coming like, then the vector, the resultant cross product will be downwards. It is in negative x direction, downwards it will be there. Suppose if it is moving in anti-clockwise direction, so we can write anti-clockwise direction like this. In anti-clockwise direction means this A bar is rotating like this. So in anti-clockwise direction, then the thumb will be indicates the upwards. Okay, top upwards of this plane of these two vectors. Okay, like that we can say here. By using that we can say here. Now the angle between A bar cross B bar and B bar cross A bar will be the 180 degrees. Okay. So next third one is given here. If A bar cross B bar is equals to A bar dot B bar, then angle between A and B is they are asking there. Okay. So the third one it is given. The third one, if A bar cross B bar, small a is given here. Modulus of A bar cross B bar is equals to modulus of A bar dot B bar. So here we can write there A bar cross B bar is nothing but by the cross product formula AB sin theta. So they given here magnitude. Magnitude means only AB sin theta will come there. Now here we should find out the magnitude, no? So here A bar dot B bar formula is AB cos theta. Now here AB and AB, it is a magnitude. So we can write like this. Now here we'll get there sin theta. Sin theta is equals to. So sin theta is equals to, we got there cos theta. If you bring the cos theta this side, it will become there sin theta divided by cos theta, that is equals to 1 will get now here. It will be 1. Then sin theta by cos theta is nothing but what there? Tan theta, no? Tan theta. So tan theta is equals to 1 we got there. When tan theta is equals to 1? When the tan of 45 degrees. For tan 45 degrees we'll get, no, that one. Okay, so we'll get here. Therefore theta is equals to 45 degrees. Theta is equals to 45 degrees. That is the answer. So what is the option? What is the answer here? Answer is option 4. Option 4. Next, fourth one is given. A vector A bar points vertically upwards and B bar points towards the south. Okay. A vector A bar points vertically upward and B bar points towards south. Then vector product A bar cross B bar is. Okay. Vector product A bar cross B bar is. Okay. This problem we'll see in the next class.